So in physics, whenever it's possible, it's always important to find the master equation that describes almost everything about a certain property or a certain force or a certain phenomenon, okay? And when it comes to fluids, there is such a master equation. And that master equation is called Bernoulli's law, all right? It's basically the culmination of everything we've learned in this chapter so far, okay? And Bernoulli's law basically just says that for any given fluid flow, at any given point, the pressure plus the density times gravity times y, which is height or elevation of the fluid, right, plus 1/2 times the density times velocity squared always must be constant, okay? For any given point in a fluid flow, like so let's say, we have fluid flowing as this diagram in the slide shows. We have this fluid flowing in a pipe like this, right? At any given point, here or here or here or here or here, the sum of these terms must be the same, okay? This explains almost everything, okay, about fluids. Locked inside of this relationship is everything you need to know, including why planes stay up in the air. So for example, I'll use this example if you guys can go 2 slides ahead to where it says this principle gives rise to the magic of flight, okay? So if you look at a plane, right, so like let's take the cross-sectional area of a plane wing, right? It looks like this, okay? The air that flows along the bottom, right, covers a little bit less distance and therefore is a little bit slower. So the velocity on the bottom of the wing is a little bit slower, right? But over here on top, the air has to cover more distance in the same amount of time, so the velocity is a little bit faster, okay? Well, what happens if you decrease velocity, but this whole term has to stay constant, right? If you decrease velocity and this term has to stay constant, and height's not changing, right? You're not really changing much in terms of elevation over this wing, right? So that means the pressure must increase, right? And then on the top of the wing, so here you're going to have pressure increase underneath, okay? And above the wing, right, if your velocity increases, if this whole term is going to stay constant and the elevation is not changing, then the pressure must go down. So up top, the pressure is going to decrease, right? This creates the lift that you experience anytime that you take flight. Pressure on the bottom of the wing is more than the pressure on top. That creates a net force in the upward direction. Plane wants to take off the ground.